Hello, here we have a polynomial, p of x equals 7x cubed minus 18x squared plus 5x plus 6, and we want to know, is x plus 1 a factor of this polynomial? How can we find out? Well, we had that factor theorem that says that in order for x minus a number to be a factor, that number has to be a 0. P of that number has to come out to equal 0. So we can find out if that really happens here or not with synthetic division. Now remember, when you set this up, if I'm dividing by x plus 1, the number I have to put out in front is the number -1. And I've got 7, -18, 5, and 6 here. Now that it's set up, let's start adding and multiplying. Just start by bringing down this 7, then multiply -1 times 7, and we get -7. Now add -18 plus -7 is -25. Multiply -1 times -25 is +25. Add 5 plus 25 is 30. Multiply -1 times 30 is -30. Add 6 plus -30 is -24. So nope, not a factor, because we did not get a remainder of 0. For x plus 1 to be a factor, we would have to get a remainder of 0 when we did this synthetic division where we were dividing by x plus 1. Okay, what about x minus 2? Is that a factor of this same polynomial? Well, let's check. Set up the synthetic division. This time we're dividing by x minus 2. So the number 2, good old positive 2, goes out in front. And same coefficients. So bring down the 7. 2 times 7 is 14. Add -18 plus 14 to get -4. Multiply 2 times -4 to get -8. Add 5 plus -8 to get -3. Multiply 2 times -3 to get -6. And add 6 plus -6 to get 0. Yes, x minus 2 is a factor of this polynomial. I know that because the division came out even. I got a remainder of 0. So that tells me that p of 2 equals 0, and that x minus 2 is a factor of this polynomial. I can factor it into x minus 2 times something else. What? What's the something else? Well, that would be the quotient. X minus 2 times 7x squared minus 4x minus 3. Now, it turns out that that 7x squared minus 4x minus 3 can be factored even further. You can break that apart using the good old factoring methods you learned way back when. It breaks up into 7x plus 3 times x minus 1, because if you FOIL that out, you get 7x squared minus 7x plus 3x, so there's your minus 4x minus 3. So look at all these factors. You got x minus 2 times 7x plus 3 times x minus 1. And that means that the zeros of this polynomial are 2. Well, we knew 2 was a 0. But then also you have a 0 when 7x plus 3 equals 0. That would be when 7x equals -3, so x equals -3/7. And you also have a 0 when x minus 1 equals 0, which is when x equals 1. So altogether, this polynomial has 3 zeros. 2 and -3/7 and 1. Last example with multiple parts, but they all relate to one another. They all kind of go together. So here we have the polynomial p of x equals x cubed minus 3x plus 2. Now, I challenge you to pause the video right now and see if you can answer for yourself all of the questions on the screen here. See if you can come up with the answers to all of these questions. They all kind of go together. Okay, when you're ready, unpause the video and I'll work you through how to find the answers. So first question, what is this polynomial divided by x plus 2? Like, what do you get for the quotient and the remainder when you take x cubed minus 3x plus 2 and divide it by x plus 2? Well, that looks like a job for synthetic division. How do we set this up? Careful, what number do we put out in front? Negative 2. We're dividing by x plus a number, so we put a negative number out in front. And then what numbers do we put for the coefficients of the dividend? Careful, notice there's an x cubed term and then a sort of missing x squared term in there, and an x term and a constant term. So the numbers we have are, after the negative 2 out in front, we have 1, 0, negative 3, and 2. For the 1x cubed plus 0x squared plus negative 3x plus 2. Now, go through with the synthetic division. Go ahead and do the adding and multiplying you need to get the numbers on the bottom row. Bring down the 1. Negative 2 times 1 would be negative 2. 0 plus negative 2 would be negative 2. Negative 2 times negative 2 would be positive 4. Negative 3 plus positive 4 would be positive 1. Negative 2 times positive 1 would be negative 2. And 2 plus negative 2 would be 0. So now can you see what we got for the quotient and the remainder? The quotient is 1x squared minus 2x plus 1. And the remainder is 0. So we've answered the first question. The quotient, what we get when we divide this polynomial by x plus 2, we get x squared minus 2x plus 1 with no remainder. The division came out even. Next question, what is p of negative 2? Well, we've already done the work. P of negative 2 should be the remainder we get when we divide by x minus negative 2, or x plus 2. What we just did. We had negative 2 out in front. We did the synthetic division. The remainder we got was 0. So p of negative 2 is 0. Next question, is negative 2 a 0 of this polynomial? Well, duh, that's what we just said. P of negative 2 equals 0, so that's what it means for negative 2 to be a 0 of that polynomial. So, yeah, it is. Next question, is x plus 2 a factor of our polynomial? Well, remember we did the division. The division came out even with no remainder. P of negative 2 was 0, so yes, x plus 2 is a factor. Next question, okay, factor that polynomial completely. So when we said it's a factor, that means we can write this polynomial as x plus 2 times something else. X plus 2 is one of the factors, and then the something else that it's multiplied by is what we got for the quotient. So it factors into x plus 2 times x squared minus 2x plus 1. Now, is that factored completely, or can we take it further? Well, we can do something with x squared minus 2x plus 1. We can factor that into x minus 1 times another x minus 1. You could write it that way, or you could write it as x minus 1 squared. So now it is factored completely. It's x plus 2 times x minus 1 times x minus 1. Or x plus 2 times x minus 1 to the second power. And what are the solutions to the equation x cubed minus 3x plus 2 equals 0? Well, remember, that's the polynomial that we just factored. We saw that this factors into x plus 2 times x minus 1 times x minus 1. So what we're really looking at here is, okay, when is that equation true? When is x plus 2 times x minus 1 times x minus 1 equal to 0? Well, that would be when x plus 2 equals 0, which is when x is negative 2, or when x minus 1 equals 0, which is when x is 1, or, redundantly enough, when x minus 1 equals 0, which is when x equals 1. So what are the solutions? Well, they are x equals negative 2 and 1, and then 1 again. So notice we started with a degree 3 polynomial. We got these 3 factors, and in a way we got 3 solutions, 3 zeros of this polynomial, but they weren't 3 different solutions. So if I ask you how many different solutions are there, or how many different zeros does this polynomial have? 2. But if I ask you, counting multiplicities, how many solutions are there? Well, there's these 3. There's negative 2, and then 1 appears twice on the list of solutions. So we call that a solution or a zero of multiplicity 2. A double zero. And another word for that would be a double root. Now, our book doesn't use the word root, but other books do call the zeros of a polynomial or the solutions to a polynomial equation the roots of that polynomial equation. So negative 2 and 1 would be the roots here, and the 1 would be a double root, a root of multiplicity 2. In the next section, we'll be talking more about, if you've got a polynomial, what could the zeros be, and how could you go about finding them? There will be a lot to talk about there, so I hope you're eagerly anticipating that.